Welcome to today's deep dive. We have a pretty massive reality check in the tech world to cover today.
Yeah, $1 billion reality check, to be exact.
Exactly. The source material on our desk revolves around this staggering pivot away from the current AI consensus. It's detailed in a piece titled "LeCun's Billion-Dollar Pivot to World Models."
It's a fascinating read.
It really is.
Yeah.
So, okay, let's unpack this. Because right now, everyone, and I mean everyone, is currently fixated on large language models.
Right, ChatGPT, Claude, all of those.
Yeah, the assumption across the board is that text-generating AI is the definitive path to artificial general intelligence. But today's source reveals a completely different, almost rebellious direction for the future of AI.
And for you, the listener, this isn't just, another industry update about some new startup or minor software tweak.
No, not at all.
It validates that curiosity you might have when you see all this hype. We're actually looking at a fundamental questioning of what true human intelligence actually is.
Right. And whether the entire tech industry is currently just running at top speed down a blind alley.
Which is a terrifying thought for investors, I'm sure. But that framing sets up the stakes perfectly, because the source material forces us to challenge the underlying architectural assumptions of these tools we literally use every day.
Yeah.
We are examining this thesis that suggests the dominant models, the ones driving all these crazy current tech valuations, might actually have a hard ceiling when it comes to true comprehension.
And the cultural landscape right now is just utterly dominated by this LLM obsession. The prevailing narrative is basically, if we just scale up compute.
Throw more servers at it.
Exactly. Throw more servers, add more parameters, feed these models larger and larger sets of the internet, they will just inevitably cross this magic threshold into reasoning.
It's treated as an absolute certainty.
Right. We treat these systems as the ultimate trajectory of innovation. But the text drops a major disruption into that narrative. Yann LeCun, who is widely recognized as literally one of the godfathers of modern AI, has left Meta.
Which is huge.
It's massive. He helped build the foundation of the neural networks the whole world relies on right now. And now he is walking away from one of the largest infrastructure players in the space.
What's fascinating here is what that departure signifies on a structural level. I mean, when an architect of his caliber steps away from a massive entity like Meta, it signals a seismic shift.
Because they have unlimited resources, right?
Exactly. Large tech companies are deeply entrenched in the current paradigm. They are building massive, multi-billion-dollar data centers specifically optimized for language models.
Yeah.
So for an insider to step away, it implies that the foundational architecture heavily invested in by his former employer might be fundamentally flawed for the ultimate goal of generalized intelligence.
It's a huge divergence in philosophy.
Right, a divergence that couldn't be reconciled within the walls of a company entirely committed to the LLM path.
And the language he uses to describe that LLM path is incredibly sharp in the source text. He doesn't just, politely suggest a pivot.
No, he doesn't hold back.
He actively calls the current hype surrounding language models a delusion. He goes as far as stating they are a dead end for true human intelligence.
A dead end. That is a massive indictment of the technology defining this decade.
Yeah, so why use a word as scientifically and psychologically heavy as delusion to describe systems that are, successfully passing medical exams and writing functional code for people?
Well, we have to analyze the mechanism of that delusion. A delusion is a false belief maintained despite evidence to the contrary, right?
Right.
The source points to the idea that the tech industry has been seduced by fluency.
Seduced by fluency. I like that.
Yeah, because these models are so adept at mimicking human syntax and stringing words together in statistical probable ways, they create a highly convincing illusion of comprehension.
It feels like there's a person on the other side of the screen.
Exactly. We as human beings are biologically wired to associate language with thought. When a machine speaks to us eloquently, we naturally project a mind onto it.
We can't help it.
We really can't. So the delusion LeCun is pointing to is our collective assumption that because the machine can manipulate language, it actually possesses an underlying understanding of the concepts those words represent.
Ah, okay.
He is attempting to shatter that mirror. He's arguing that statistical word prediction is not a stepping stone to reasoning at all. It is merely a highly sophisticated parlor trick that has essentially reached its architectural limits.
That introduces a really crucial distinction between mimicry and comprehension. It makes you reconsider the actual utility of interacting with these models.
Absolutely.
Because if they are just predicting the next logical word based on a vast database of text, they aren't reasoning through your problem, they are just regurgitating
Just
patterns.
highly probable patterns.
Right. But LeCun is doing more than just publishing academic critiques here. He is making a massive financial maneuver based on this thesis.
Putting his money where his mouth is.
Big time. The source highlights that he has raised $1 billion for a brand new startup named AMI.
1 billion.
Yeah. That transitions this whole thing from a theoretical debate on Twitter to a structural bet against the current consensus.
If we connect this to the bigger picture, the sheer scale of that investment is incredibly telling.
How so?
Well, raising $1 billion for a brand new entity like AMI in the current venture capital climate represents an extraordinary level of conviction.
Yeah, you don't get that kind of cash easily.
Exactly. You do not secure that level of funding simply to build a slightly more efficient language model or a niche software tool. $1 billion seed is foundational capital.
It's built an entire industry money.
Right. It indicates that major institutional investors have reviewed his argument that the LLM architecture is a dead end, and they concluded that a completely new structural foundation is required for the next era of AI.
They bought into the vision.
They bet that the current trajectory will stall, and a fundamentally different approach will be necessary to achieve the next major leap in capability.
Just imagine the confidence required to execute that pivot. In an environment where the pressure to conform and just build wrappers on top of the existing LLM infrastructure is immense.
The pressure's everywhere.
It really is. Taking $1 billion to walk in the exact opposite direction is a profound display of independent thinking. It really is a reminder of the value of going against the grain.
Even when the rest of the world is going one way.
Right. Which forces the question, what exactly is AMI building that requires starting completely from scratch? The source identifies their core technology as world models.
World models. This represents the crux of this entire billion-dollar pivot. It is a complete departure from the mechanics of an LLM.
Okay, here's where it gets really interesting. The crucial difference outlined in the source is that AMI is building artificial intelligence designed to understand physics rather than just words.
Physics, not text.
Yes, they are moving away from language as the foundational training layer and attempting to teach the machine the physical rules of reality.
Let's break down the architectural implications of that shift. An autoregressive language model, an LLM, operates entirely in the abstract domain of text.
Right.
If you ask it what happens when a glass is pushed off a table, it answers correctly. But it answers correctly because it has processed millions of documents containing the words glass, fall, and shatter.
It knows those words usually hang out together.
Exactly. It knows the statistical relationship. However, it possesses zero internal representation of gravity or momentum or the physical properties of glass.
It doesn't actually see the glass falling in its mind.
No, it doesn't simulate the event at all. It merely predicts the textual description of the event. A world model, by contrast, is attempting to build an internal state space. It is designed to actually understand the physical reality of the objects and the forces acting upon them.
Okay, I want to make sure we're visualizing this right. So if we look at a scenario where a machine is confined only to text, it's essentially operating in a dark room, in a vacuum.
That's a good way to put it.
Like, it has access to every script, dictionary, and manual ever written, but no sensory connection to the environment.
None.
So it can perfectly define the word friction based on a dictionary input, but it has absolutely no concept of what friction physically feels like when moving a block across a rough surface.
It has no spatial reality.
Right. It is a master of vocabulary devoid of reality. So AMI is trying to bridge that gap. They want to create a system that doesn't just know the definition of the word drop, but fundamentally grasps the physics of a falling object.
And the limitations of operating in that vacuum become really apparent when you ask an LLM to plan or reason through a novel physical scenario that hasn't been explicitly documented in its training data.
Because it can't just look up the answer.
Exactly. Because it lacks an internal model of how the physical world operates, it cannot simulate future states. It can only guess the next word.
Which is why they sometimes give those bizarrely confident but physically impossible answers.
Yes. This is why LLMs struggle with complex multi-step planning or spatial reasoning tasks. They hit a wall because you simply cannot derive the fundamental laws of physics purely from statistical text analysis.
I'm not in the text.
Right. To achieve what LeCun calls true human intelligence, The system must possess an internal model of reality that allows it to predict the consequences of actions in a physical space, just like we do.
Okay, let's challenge that concept of true human intelligence for a second. The source draws this direct line between understanding physics and human-level cognition.
Right.
Why is physical grounding so essential to the definition of intelligence? Couldn't someone argue that high-level, abstract thought like mathematics or, I don't know, philosophy is purely symbolic and doesn't require a physical world model?
That is a really fascinating counterargument. But we have to look at how human cognition actually develops in reality.
Okay.
We do not begin our cognitive development by reading philosophy. Human intelligence is fundamentally rooted in sensorimotor grounding.
Touching things, moving around.
Exactly. Long before a child learns the word gravity, they have spent thousands of hours building an intuitive internal physics engine by dropping objects off their high chair, throwing toys, and physically interacting with their environment.
They're testing the physics engine.
Yes.
Yeah.
Our abstract reasoning is built on top of that physical foundation. We even use spatial metaphors to describe abstract concepts. We talk about grasping an idea or a concept being over our heads.
Oh, wow. That's true.
Lacan's argument is that you cannot skip that foundational physical layer. If you try to build intelligence starting from the top down, starting with language and abstract symbols without any grounding in physical reality, you end up with a brittle system.
You end up with a dead end.
Exactly.
That reshapes how we view the learning process entirely. We are essentially trying to build a roof without pouring a foundation when we rely solely on text data sets.
That's a great analogy.
We are feeding these models the end product of human intelligence, our words, without giving them the mechanism that produced that intelligence in the first place, our physical interaction with the world.
Precisely.
So by shifting the focus to world models, AMI is attempting to replicate that foundational layer. They are prioritizing the physics engine over the vocabulary list.
And this raises an important question for you, the listener, regarding the real-world application of all this technology.
Right. What does this actually look like?
Well, if the industry successfully shifts from models that process text to world models that understand physics, the scope of what AI can achieve expands dramatically.
Because right now they're stuck in the computer.
Exactly. An LLM is inherently confined to digital environments. It can summarize documents, generate code, draft emails. But a robust world model is the key to autonomous navigation in the physical world.
The leap from a digital assistant to an autonomous physical agent is massive.
It changes everything.
Yeah. If an AI actually understands momentum, spatial awareness, and cause and effect in a physical environment, it completely changes the timeline for technologies like advanced robotics and autonomous vehicles.
Because the current bottleneck for a lot of that hardware is that the software can't reliably predict what will happen next in a chaotic, unpredictable physical space.
Like a busy intersection.
Right. A world model is specifically designed to simulate and predict those exact physical interactions.
The transition from predicting text to generating physical action really is the critical threshold here.
It is. Because when a machine operates in the physical world, errors are no longer just grammatical mistakes or hallucinated facts on a screen.
Right, they're physical collisions. They're dangerous.
Exactly. To operate safely, the system must be able to simulate multiple potential future states of its environment and select the safest course of action.
Sure.
You just cannot do that with a system optimized for stringing words together.
No.
You need a model that intrinsically understands that if a ball rolls into the street, a child might be following it.
That requires spatial logic, temporal reasoning, and just an intuitive grasp of physics.
The exact capabilities Lacan's world models are attempting to build.
It makes the billion-dollar investment make complete sense when you frame it like that. They aren't just trying to build a slightly better chatbot.
No, they are trying to build the operating system for the physical integration of AI.
Taking the technology out of the browser and putting it into the tangible world.
Yeah.
But stepping back from the specific applications for a second, there is a broader narrative here about the nature of innovation itself. The source illustrates a scenario where the entire tech ecosystem is experiencing this unprecedented gold rush in one specific direction.
Driven by massive corporate momentum.
And public hype.
The institutional inertia behind LLMs is just staggering right now. When billions of dollars are committed to a specific architectural path and entire product ecosystems are being built around it, questioning the fundamental viability of that path becomes incredibly difficult.
The industry essentially develops a blind spot.
They do. And Lacan's pivot serves as a critical case study in the necessity of contrarian thinking in technological development.
Because true progress rarely resembles a straight line of iterative improvements on a popular concept.
No. Often it requires the rigorous identification of a paradigm's fatal flaws and the willingness to completely abandon the popular consensus to build an entirely new framework from the ground up.
So what does this all mean? We've traced the trajectory of this disruption from the initial skepticism to the billion-dollar execution.
We covered a lot of ground.
We did. We started by examining the overwhelming cultural delusions surrounding large language models, dissecting why their fluency masks a deep architectural inability to actually comprehend the world.
Right.
We looked at Jan LeCun's high-stakes departure from Meta and his massive financial pivot to launch AMI. And we dug into the fundamental technological shift from systems that merely predict the next word in a sentence to world models designed to understand the physical laws of gravity, momentum, and spatial reality.
And the synthesis of these points provides a crucial lens for evaluating the future of this industry. We are witnessing a fundamental debate over the architecture of intelligence itself.
It's historic.
It really is.
Yeah.
Will the future be dominated by increasingly massive statistical text engines? Or will the paradigm shift toward models grounded in the physical mechanics of the real world?
Right.
LeCun's billion-dollar bet strongly suggests that the ceiling for text-only AI is much lower than the current hype implies, and that the next major breakthrough will require an AI that doesn't just read about the world, but actually understands how it works.
That is a perspective shift that completely changes how we should evaluate the tech news cycle moving forward. We want to thank you for joining us on this deep dive into the underlying architecture of tomorrow's technology.
It's been a great discussion.
Before we wrap up, we want to leave you with a final thought to mull over. We've spent this time analyzing how an artificial mind might need to understand the physical laws of a bouncing ball or a falling object to achieve true intelligence, rather than just mastering language.
Yeah.
It forces us to look inward at our own cognition. If true human intelligence is so deeply reliant on an innate understanding of physical reality, what does that say about the limits of our own digital lives?
That's a great point.
As we spend more and more of our time interacting with screens, manipulating symbols, and living in text-based environments, are we slowly distancing ourselves from the very physical grounding that built our intelligence in the first place? Think about the complex physics your brain calculates intuitively just to walk down a crowded street. Until next time, keep questioning the consensus.